Hi and welcome back. So on the last video, we finished the topic 2.6.3, which is about how you can represent um, combined transformations. So we combined translations and rotations, and this way we are able to accomplish some desired transformation. And as I said to you on this video, we will work on, we will solve the, the example 2.8, and solving this example, we will able to get a better look on how these combined transformations um, are done. So I'm gonna write the problem. So let's say that we have a point P, and this point it has a it are um, in some specific position and is linked on the referential F and OA as we done right here. And this point is subject in a series, uh, sorry, to the following, is subject to the following transformation. So we have a point in some specific position or location, and this point will suffer some transformations of rotations and translations. So the first transformation is a transformation of rotation of 90 degrees around the axis, around the axis Z. And after that, a second transformation is applied, which is a rotation, also a rotation transformation, also of 90 degrees, around the axis Y. And we have a third transformation, but now is a transformation of translation. Translation and at this point you are able to to know what it is, a rotation, a translation, and remember um, when we apply the transformation of translation, we are decomposing the position of the point in cosines and sines, and it is the transformation that changes the position, the rotation of the point. And this example, it asks for us to the coordinates, find the coordinates of the point in relation to the ref system, to the reference system. So if we look back, if we go back to the last video where I told to you that it is much easy if we work with these notations, then all the time we draw the reference systems, and is the way that we work this type of problems. Um, we will also have to go back um, even more, one of two or three videos where we work um, the notations of pure rotation above the axis x, above the axis z, and above the axis, above the axis y and above the axis z. And we have these characteristic matrices, and I'm gonna copy this because we will use right now. So let me copy this and paste right here and make it smaller. Okay, so let's apply this notation. Let me copy this notation. Okay, right here. So we are applying a transformation of translation with these coordinates. So the point it will be decomposed on sines and cosines based on this transformation. So we will be left with the following is a translation occurring changing to these coordinates. Okay, now the rotation of 90 degrees around the axis z and the rotation of 90 degrees around the axis y. So is a rotation transformation above the axis y of 90 degrees and the rotation above the axis z of 90 degrees and time times the fixed reference system linked on the fxyz system. So we have this characteristic matrix of translation, and if you look at the video about a pure translation movement, you will saw that a when we are doing a pure translation movement, uh, the diagonal uh, of this matrix we will be filled with ones, and that because these ones on the diagonal of this matrix represent the unit vectors and the zeros represent any component uh, out of the each axis. And the fourth row of the matrix is scale factor that we add to keep this matrix on the quadratic form. So if you don't remember, we have some axis system x, y, z, and when pointing on each direction, so let's say that that is for x, y, z, and this is the new coordinate of the point. And for x is 1 as pointing on this direction, and as this axis or unit vector are not decomposed on any other component, the rest of the terms on this column will be 0, and is the same for the other axis. For the axis y, on the for the axis y, we have any component for x, just for the axis itself pointing on this direction. So we place it, we fill it with 1, which is the length of the unit vector, and we also don't have any component for the z-axis, and the same for z. We do not have any component for x, any component for y, and just pointing on the direction of the z-axis, so we fill it with 1. So that's it. And for a pure rotation, above the axis y, so substituting right here this term cosine of 90 is equal 0, so cosine of 90 equals 0, and sine of 90 is equal 1. Sim, nada. Tchau. Até nunca mais. Chega de tratamento. And adding a fourth row to make sure that this matrix keep this quadratic form. And the characteristic matrix of the when we are doing a rotation above the axis z, but of 90 degrees, and substituting this, we are left with this matrix. And multiplying by the position, by the rotation, the old position, the old orientation of this point, which we got right here. And after these transformations, the orientation of the point will be given by this new rotation. And now let me draw what happened on each transformation. So there are three. That is the first transformation. O1, A1, N1. Now the second transformation. A2, O2, A2, and N2. And the third and last transformation. This third transformation is the translation transformation. So as you can see, as we are applying the first one and the second one as rotations above some axis, the position itself of the point, it doesn't change, but when we apply this third one, which is a translation, we will have this point um, decomposed in coordinates and the referential, which is the point itself, where it will change as we are applying this transformation of translation. So the point itself, the coordinates of the point, it will change. Sorry, right here is we are doing scale. Right here too is scale. Okay, so that is the final position, the final rotation of the point of this successive transformation. So let's repass this. We have a point on some specific position or rotation on the plane, on the 3D plane, on the space, and this point is linked on the reference system F and O, and this referential system, which is fixed and linked on this other referential system, this ref system F and O is the ref system that we call rotation reference system, which are linked on the ref system fxyz. And he passed to us the transformations that are being needed, which is a rotation of 90 degrees above the axis Z, and followed by a rotation of 90 degrees above the axis Y, and a third and last transformation of translation, and that is the transformation that which changes the orientation and position of the point, and that's it. And applying these successive transformations, we are able to track the final position or rotation of the point, and which is this one that we are draw. Okay.